In this video, we're going to be talking about solving quadratics in vertex form. So let's take a look at our first example here. This is a quadratic. If I expand this out, I'll get a power of 2. We have a quadratic equation here. The idea here is you don't actually want to expand it out. If you have a quadratic that is in vertex form, like we see here, right? This is in vertex form on the left-hand side. You don't want to go to all the trouble of expanding all this out, bringing everything over, trying to factor, when there is an easier method when you have something in vertex form. What you do is you want to isolate for x. So the first thing I'm going to do here, before I can isolate for x, I'll have to take the square root. Before I can take the square root, I have to get this pluses and minuses out of the way. So in this case here, the first thing I'm going to do is I'm going to add 3 on both sides of the equation. By doing that, I end up getting x minus 2 squared equals 25. So I want to solve for x. I want to get x by itself. Before I can do that, I have to get rid of this power of 2. To get rid of the power of 2, I'm going to take the square root of both sides of the equation. So if I take the square root of both sides of the equation, what ends up happening here is these two will cancel off. And the reason for that, in case you don't remember, the square root of x in exponential form is x to the power of a half. So if you have a situation where you're taking the square root of x squared, that's really x squared to the power of a half. And we know when you have power to a power, you multiply, giving you x. So this will reduce to become x minus 2 equals. Now when you take the square root, you have the possibility of a positive and a negative number both working for that. This ends up being plus or minus 5. And now I want to go ahead and solve for x. So I'm going to add 2 to both sides. I get 2 plus or minus 5. If you do 2 plus 5, you get 7. And 2 minus 5, you get negative 3. So the roots of this equation are 7 and negative 3. Okay, let's try another. All right, let's take a look at the next equation. So again, I want to solve for x here. I don't want to expand this out, collect like terms, and try to factor this. Instead of doing that, I'm going to leave it in vertex form. I'm going to move the positive 9, divide out the negative 3, and then take my square root. So first step here is to move that positive 9. So we're going to subtract 9 on both sides of the equation. By doing so, I get negative 3. X plus 5 quantity squared is negative 9. Now I want to take my square root, but I have to get rid of this minus 3 first. So we're going to divide across by minus 3. These cancel. I get x plus 5 quantity squared is now 3. Take the square root of both sides. Keeping in mind it leaves the option of both a positive root 3 and a negative root 3 as working. And the reason for that is because that's a power of 2. And now if I solve for x, we subtract 5 on both sides. And I get negative 5 plus or minus the square root of 3. So here are our two roots here. And you would leave it in this form. Okay, let's try another. So same idea here. I want to solve this quadratic. I have a vertex form on the left-hand side. Don't expand it all out. First step, like we've been doing here, is let's go ahead and add 8 to both sides of the equation. When I add 8 to both sides of the equation, we end up getting 1/2 x minus 3 quantity squared is 13. Again, now I want to solve for x, but I got to get rid of this coefficient in front. The ones we've been looking at, you've had a 2 or 3, and we've been dividing across by those numbers. Now I have a half, so I'm going to actually multiply across by 2 to cancel off that half. And by doing so, now I have x minus 3 quantity squared is 26. Now we take the square root of both sides of the equation. This leaves the option of a plus or minus as both working. And then we add 3 to both sides. And there we go. Okay, let's try another. Again, I have a quadratic in vertex form. Don't expand it out. Don't bring everything to one side. There's a quicker way. And that quicker way is to take the square root of both sides of the equation. So if I take the square root of both sides of the equation here, we end up getting x plus 10 equals plus or minus. The square root of 121 is 11. So you'll see here we have x plus 10 equals plus or minus 11. X equals negative 10 plus or minus 11. So you have two answers here. Negative 10 minus 11 is negative 21, and negative 10 plus 11 is 1. So these become my two roots. Okay, quick little lesson today. That's just talking about the idea is if you have a quadratic that is in vertex form, right, you can solve it much quicker leaving it in vertex form as opposed to expanding everything out and bringing everything to one side. So study these four examples. These cover most of the ideas that you'd come across involving solving quadratic equations in vertex form. Thank you.